Here's a set of problems that is all dealing with graphing. When you take your test over Chapter 2, you're going to have a section that's going to be set up the same way. The directions are just going to say graph the following, and it's going to be a mix of different types of graphs, and you're going to be given a grid to do each of your graphs. So what you have to think about is it a basic line? Is it an inequality where I have to shade? Is it piecewise? Is it absolute value? Just thinking of all the different graphs that we've done throughout the course of the chapter. So we're going to work through that. We're going to look at 6 different graphs so you have a good sampling of what we've done. First one is asked you to graph negative 2x plus 4y equals 10. When you are graphing basic lines, keep in mind that you're considering whether it's in slope-intercept form, which means the y is by itself, or if it's in standard form. That's what this one is. If it's in standard form like this one, I think the easiest way to go is to do the cover-up method, meaning that I replace my x and y with 0 each separately to find the intercept. So I'm going to start with the x-intercept. I'm going to get rid of the negative 4y. I'm going to let that go to 0. My x-intercept is found by taking negative 2x equals 10, divide by negative 2. So we get x to be negative 5. That is a point on my x-axis, so I'm going to go on my graph and I'm going to put a point there now before I forget. And then my y-intercept is found by letting x be 0, so I get 4y equals 10. Divide by 4, I get y to be 5 halves, or if you want to think of it as a decimal, 2.5. So I'm going to go on my y-axis up 2.5 spaces, and then connect the dots. This was the first type of graphing that we did in the chapter, just basic linear graphing, no shading, no inequalities, no absolute value, no piecewise. Second one that's on here is an inequality graph. When you see the inequality, the first thing you want to notice, because it has a less than or a greater than or less than or equal to, you need to think about if your boundary line is going to be solid or dotted. You also have to remember to shade, which can be one of the toughest things to think about. When you're looking here, you realize that it only has y's. If it only has y's, then you want to isolate the y. So we're going to subtract 3. You get negative 2y is greater than 8. Divide by a negative 2. Because I divided by a negative, I have to switch the inequality. When you have an inequality or an equation that is only with y's, your boundary line, your line is going to be horizontal. So when you graph your boundary line, you're going to go down to negative 4 on the y-axis. Before you draw it, you want to think, since it's an inequality, if you want your boundary line to be dotted or solid. Because it doesn't have the or equal to, it will be a dotted line. So I'm going to draw my boundary line. I am looking where the y is less than negative 4. Less than is going to be underneath the graph. So the shading that I'm going to be looking for is that you shaded beneath your boundary line. So when I grade this, I am looking to see if the boundary line itself is correct, if it's the right line versus dotted versus solid, and if your shading is in the accurate place. Here's another one that is an inequality. This time it's an inequality in slope-intercept form. So I'm going to graph it using the same techniques that we used at the beginning of the chapter. This is my y-intercept, so I'm going to start at 3. My slope is negative 1 over 4, so that means I'm going to go down 1, right 4. So down 1, right 1, 2, 3, 4. Before you connect the dots, double check dotted versus solid boundary line. This will be a solid line because it has the or equal to, so you can go ahead and draw it in. And then finally you have to decide where to shade. Whenever it is in slope-intercept form, it's the easiest. You are just shading under if it's less than, above if it's greater than. If it's in standard form, you have to do a little more work with a test point. But since this one is in slope-intercept form, I can immediately shade underneath my boundary line because it is a less than inequality. Now moving on to piecewise. Piecewise are the most obvious because you see that bracket, you see multiple equations. When you're dealing with your piecewise function, the most important x value is the x value where the equations switch. In this case, the x value where everything switches is at 4. What you want to do is plug 4 into both equations, the top and the bottom. What that's going to do is it's going to tell you where one of the rays stops and where the other ray picks up. So if I put 4 into the top equation, and here's where you can use your calculator. You can use a table function on your calculator, or you can do it in your head. Negative 4 plus 3 is negative 1. I'm also going to put 4 into the bottom equation. So I have half of 4 minus 3. That's 2 minus 3, which is negative 1. Since you get the same number, what that's telling me is there's not going to be a gap in this graph. One of the rays stops at the exact same spot that the other ray starts. And because of that, you don't have to worry about open versus closed circle. It will only be 1 point at 4, negative 1. Now to finish it, we have to know what the rays look like, the one heading left and the one heading right. So what you want to do is pick a number that is less than 4, any number that's less than 4. I'm going to pick 0. It's so easy to plug in. And then when I plug 0 in, I get 3. that gives me the ray that's heading to the left. So if I graph 0, 3, it's up here. That tells me that this ray looks like that. And then with the other one, I want to pick a number bigger than 4. I'm actually going to pick an even number. You could pick any number. You could pick 5. I'm going to pick 6 just because I notice in my equation I have to take half of that number. And it's a lot easier to take half of an even number. So half of 6 minus 3, that's 3 minus 3. That's 0. That tells me that this ray, and I'm going to have to extend my graph a little bit, this ray goes through 6, 0, and looks like this. We talked about how piecewise functions could look a couple different ways. You could have a gap in your graph, or in this case you have one stopping and starting at the same point, so you do not have any type of gap in your graph. I've got one more piecewise, and then we'll finish with an absolute value. Here's a piecewise. The tougher thing about this piecewise function is it has 3 equations. The easy thing about this piecewise function is all of the equations are numbers. They're constants. And since we notice that these are all just constants, that means when I graph them, they are going to be all horizontal pieces. They're going to look like a series of steps. We have 2 x values that are important. -1 is one place where it switches, and 3 is the other place. So I'm going to put -1 into the top and the bottom. Because it's a constant, when I put -1 in the top equation, I always get -3. On the second equation, when I put -1, I always get 4, because that's what this constant is equal to. If I pick a number less than -1, like -2, I still get -3. For the middle piece, now I don't have to guess what number I want to pick. It tells me that I want to pick 3. The middle piece will be the easiest because you'll know exactly the 2 x's you want to plug in to get those 2 points. You want to plug the first x in, which we've already done, and we want to plug 3 in. We also get 4 because this middle one is always, it has a height of 4. And then the bottom one, again, start with 3. That's the second changing point. I get a height of -1 because that's your number here. And if I pick any number bigger than 3, I still get -1. When I graph these, they should be horizontal. Now, you do want to look at where you want to put your circles. You want a closed circle at -1, -3. And then it goes towards -2, -3, which is here. So here's the first horizontal piece. That is a ray. The middle piece won't be a ray. It'll be a segment. It starts at -1, 4, which is up here. And it is an open circle. And it finishes at 3, 4. It's also an open circle. So this middle piece that didn't make it very straight, it should be a little higher. It should be up here a little bit. Also is horizontal. And then the bottom piece starts at 3, -1. It is a closed circle, and it continues in the direction of 4, -1. So you have a series of steps. You just have to decide what height to put the step, that's what the constants tell us, and which circles are open versus closed. The last problem is an absolute value. Remember, absolute value should look like a V when you're done graphing it. If this number is positive, it will open up, which it does here. If it's negative, it will open down. The numbers that are with x tell me how it shifts. Because this is a +2, it's going to shift to the left 2 spaces, and it's going to shift, because this is a 1, it's going to shift up 1 space. So I'm going to be going over 2 to the left, and then I'm going to go up 1. Here is the vertex of this V, this absolute value graph. The number in front of the absolute value will tell me the slope. So because it's bigger than 1, it's going to be narrower than the traditional absolute value graph. What I'm going to think of is a slope of 3 over 1. So I'm going to go up 3, right 1. And then since it's symmetric, I'm going to do the exact same thing on the other side, creating this much skinnier V, some of the other graphs we looked at. Double check that it opens up. Double check that your vertex has shifted. If it asks you where the vertex is, you can write that the vertex is at -2, 1. If it asks you if it opens up or down, you can say up. If it asks you about the width of it, you can say that this is a more narrow graph than your traditional absolute value. Here's 6 graphs. These are all things that will show up on your Chapter 2 test that you should be able to graph by yourself.